Okay, this is concept number 2, which is again simplifying rational expressions, but now we're dealing with a polynomial over a polynomial. So it's going to look a little bit different than the last section where we just had a monomial, which remember was one term. Now I've got something larger, either in the numerator and in the denominator. Maybe it's just in the numerator. They're all going to look a little bit different, and you're going to approach them a little bit different depending on what type of polynomial you have. Sometimes the factoring is already done for you. Sometimes you have to do the factoring and then cancel. It just depends on what you're given. So if we look at this first slide, the factoring is already done here. Okay, this is given to you as an x plus 2 times an x plus 5. All of that is being divided by x plus 2 and x plus 7. Okay, remember rational expressions are fractions. Okay, rational is a fraction. So I'm dividing this numerator by this denominator. What you can do when they're polynomials and when they're already factored for you, you can cancel out common factors. Okay, so we cannot just cancel out common terms. It has to be an entire factor that is exactly the same in the numerator and in the denominator. Okay? Which makes sense because remember, anything divided by itself is really 1, which is why we're allowed to cancel here. So x plus 2 divided by another x plus 2 really becomes a 1, so we can just cancel those out. When you do that canceling, you're then left with an x minus 5 in the numerator that did not cancel, and an x minus 7 in the denominator that did not cancel. So your final answer for that is x minus 5 divided by x plus 7. Now, something else that gets added into these answers is what we call restricted values. All that means is what numbers, if x were equal to those, would turn your original denominator into a 0. Remember that you were never allowed to divide by 0. So because of that, there are certain values that x is never going to be allowed to be in each of these problems. So in this example, I have 2 values that would turn this denominator into a 0. If x was a negative 2 plus 2 would give me a 0 here in this parenthesis, which is not allowed to happen. So x is not allowed to be a negative 2. Also, negative 7 plus 7 would give me a 0 for this parenthesis in the denominator. So because of that, x is not allowed to equal negative 7. Okay? It's anything that will turn your denominator equal to 0. The numerator can be whatever it wants. Denominators are not allowed to be 0 because remember, you're never allowed to divide by 0. So if we look at the second example, again, this is already factored for you. I have x plus 8 times x minus 1, and in the denominator is x minus 1 times an x minus 9. Okay, so again, we're dividing. I'm taking this entire numerator and dividing by this denominator. So again, if I have any factors that are common that are exactly the same, I can cancel them out. Well, they both have an x minus 1. And it's okay that they're diagonal from each other technically. They're not right above each other. They're in the same fraction. Okay, this is all in one fraction, so you can cancel. 1 in the top, 1 in the bottom can cancel out. So the x minus 1s are both gone, which means you're left with an x plus 8 in your numerator and the x minus 9 in the denominator. Now, restricted values for this one, again, just looking at your denominator, what's going to turn these parentheses into zeros? 1 minus 1 would give you a 0 here, so x is not allowed to equal 1. And 9 minus 9 would give you a 0 in this set, so again, x is not allowed to equal 9. So it's just an equal sign with that diagonal slash through it. Okay, those are your restricted values. It's what x is not allowed to equal. Now, when we go to this second set of examples, you have to be really careful and make sure that these factors match exactly. Okay? In this first example, I have an x minus 4 in the numerator and an x minus 3. The denominator is a 4 minus x and an x plus 6. Even though this x minus 4 and this 4 minus x look very similar, They're not exactly the same. In my numerator, my 4 is negative, but in the denominator one, the 4 is a positive, which means they're not exactly the same. So they cannot cancel how they are written right now. However, you can change one of them, okay? And it doesn't really matter which one you change. A lot of times it's just the easiest to do this step with the numerator, but you don't have to. But a lot of times you'll see us do them with just the numerator. In order to make these cancel, I need to force them to be the same thing. So I can do that by multiplying one of them by a negative 1. So I can multiply this numerator by a negative 1, which will force this to actually be the same as the 4 minus x in the denominator. Then those will cancel. So you can cancel them out, but you have to replace it with a negative 1. Okay, then I still have an x minus 3 left over in the numerator that gets attached to that negative 1 that I had to put in its place. And the x plus 6 is still left over, so it goes in the denominator. Same thing with your restricted values. Go back to your denominator. What's going to make each one of these parentheses equal to 0? Well, 4 minus 4 would give you a 0 for this set, so x is not allowed to equal 4. Negative 6 plus 6 would give you a 0 there, so x is not allowed to equal a negative 6. Remember, restricted values, you have to go back to the beginning and imagine the piece that you crossed off still being there. Okay, it's not anymore, but for restricted values, you have to pretend that it is. All right, so now, same thing in the second example. We have an x plus 10 times an x minus 2, and then a 2 minus x times an x minus 3. So again, 2 minus x and x minus 2 are not the same thing. So we have to force them to be the same by replacing the 1 in the numerator with a negative 1. So I can now cancel those out, and I put a negative 1 in the numerator to take that place. Then you get a negative 1 left over, an x plus 10 left over in the numerator, and an x minus 3 left over in the denominator. Okay, restricted values here are going to be a positive 2 and a positive 3 that x is not allowed to equal. All right, now, this next set and from here on out, your factoring's not done for you. So this goes back to the very end of quarter 3 when we were doing factoring of different types. 49b squared minus 28b. 35b squared minus 35b. So I cannot just cancel terms. The entire factor has to be exactly the same to cancel it out. So I can't cancel anything here the way this is written. However, you need to try to factor out a GCF first. Okay? Remember when we did factoring, we always looked for a GCF first. So in my numerator, 49b squared minus 28b, its GCF is a 7b. So I'm left with 7b minus 4 inside. Denominator, GCF is a 35b. When I divide that out, I get b minus 1 left over inside. So this is just reviewing factoring out a GCF, which we did at the end of quarter 3. Now that you have the numerator and the denominator factored, now is when you're going to try to reduce here and kind of cancel like we did in the original examples. So I can reduce, my factors are not exactly the same, 7b minus 4 and b minus 1. Those are not exactly the same, so those do not cancel. However, I can reduce these monomials out front. So this is just like previous section, okay, just like concept number 1. 7 and 35 reduce, so you're just left with a 5 in the denominator from that, and your b's completely cancel out. So, again, 7 divided by 35 gives you a 1/5 technically, and your b's completely cancel. So in my numerator, this whole 7b is gone. I'm just left with 7b minus 4. In the denominator, I have a 5 left over, and the original b minus 1. All right, now in the next one, 18n squared plus 27n divided by 18n squared plus 36n. You cannot cancel these 18n squareds out. I know that they are the same. However, we're not allowed to just cancel terms. Okay? They have to be a factor. They have to be held together by multiplication like we had here. So I have to find a GCF first from each set. 9n is your GCF. In the numerator, you're left with 2n plus 3. 18n is the GCF in the denominator. You're left with n plus 2. These factors are not the same. However, you can reduce those monomials out front. 9 divided by 18 reduces to a 1/2, and your n's completely cancel. So in the numerator, you're just left with a 2n plus 3. The denominator, you're left with a 2 out front and an n plus 2. So you have to be looking for a GCF first if the factoring is not already done for you. Now, in these next two examples, again, the factoring is not done for you. So in my numerator, I have a p squared minus 8p plus 7. Again, start by looking for a GCF. There isn't one here, and that's okay. So I'm just going to factor that trinomial. Remember, I need numbers that multiply to give me a positive 7, but when I add them, give me a negative 8. So p minus 7 times a p minus 1. Now, in the denominator, this, your leading term, your p to the second power term is negative. You always want your leading term to be a positive. So if this happens where your leading term is a negative, factor out a negative 1. All that's going to do is change the sign of everything inside of there. So this becomes a p squared minus 9p plus 14. Then you can factor it just like normal. So then that factors, again, you need multiples of 14 that will add to give you negative 9. So the negative 1 stays out front. You have a p minus 7 and a p minus 2. That'll multiply to give you positive 14 and add to give you a negative 9. Now that you factored it, now it's just like the top two examples here. The factoring is done, so you find your common factors and cancel them out. Okay, so you just had to do the initial factoring. P minus 7s both cancel. You're left with a p minus 1 in the numerator and a negative 1 times that p minus 2. You can distribute that negative 1 in if you would like to, so both of these are correct answers. Same thing happens in the second example. You have to factor out a negative 1 out of that numerator first, since your leading term is negative. Then you factor just like normal. Okay, so you're going to factor the numerator, factor the denominator, cancel out the same terms, and then rewrite what you have left. All right, let's look at the ones on the back. Same initial steps. Okay, you have to do the factoring. But you also have to recognize what type of factoring there is. So in these two examples, your numerator is a binomial. So you need to start with a GCF there. I can pull out a 10, which leaves us with n minus 3. That's all the factoring you can do there is pulling out a GCF. However, in the denominator, you can factor it like normal. N minus 3 times another n minus 3. Then again, cancel out anything that's exactly the same and rewrite what's still left. Okay. Restricted values, again, just practicing those. What is n not allowed to equal? These factors were exactly the same, so you really truly just have one value that n's not allowed to equal, and it's a positive 3. Same thing in the second example. That denominator, all you can do is factor out a GCF. Okay? But the numerator, you can factor that trinomial into two binomials. And then again, cancel anything that is left over. Okay. These two examples include some difference of squares. Remember, there has to be subtraction in the middle, and they both need to be perfect squares in order for them to factor. Okay. So, and then again, you're just canceling and seeing what's left over. Bottom example is the toughest. It's the most work with the factoring. They both have a GCF first that you need to pull out. Then you have to factor what's left over from pulling out the GCF and then cancel. So you can go through those examples to practice them. But again, this is concept number 2, which is still simplifying rational expressions, but now we're dealing with polynomials instead of monomials.